Cool, thanks, Kevin. I'll dig into some of the things that Evgeny and I and others have mentioned across the sessions, and talk about ZTNA. So with respect to ZTNA, if we go back a little bit ago, if you guys hadn't seen this slide, it'd been used a couple times, but the title's changed here. So really, working from anywhere, it is the new normal. And the people being able to be at home or be at an airport or be on the corporate network changes all the time, right? So this flexibility is really key. And so what do you do for these applications that you need to provide security for when people are off the network? And we'll talk about different approaches to that. One thing that's important here, though, and it will affect the rest of the world and all of the vendors, even if they're not inside of the US, is this executive order and push towards cybersecurity and whatnot, and combining those two things together also with things like ransomware attacks and whatnot. From a threat perspective, security is obviously critical. And maintaining access to your applications and your services and your servers and your VMs and things like that is really important, regardless of where they're located at, and regardless of if someone like Biden says, you need to do this, that's still going to push out and kind of reverberate through the community in general, because zero trust has been doing such things for a long period of time, and more and more people are jumping kind of on the fact that that is really a key enabler for access to applications. And so when you need to do this and when you need to provide that access, the two key things that we talked about a little bit in the past are VPN and ZTNA. And so Zero Trust Network Access is that acronym. Virtual Private Network is VPN. What people have been using for VPN for a really long time, as we talked about in a session earlier today, is that some of that has been VPN concentrators. And there's also complexity that we haven't really talked about, where I think Evgeny was talking about, you might have access to and be in Europe and need access to a data center, and it lives in New York, and backhauling traffic through that can slow things down. That's true, but there's also a complexity where I might have multiple data centers. What if I have a few different data centers and my VPN concentrators only go to one of those data centers? I have to kind of learn to switch between the VPNs and use the right one at the right times. I have to make sure that I know from an IT and deployment perspective that I have a certain number of users over here, so I have a certain number of appliances that I might need to deploy, or virtual appliances or whatever, and then all of a sudden something happens like COVID, and there's just a huge onslaught of connectivity that wasn't like that before. But one of the key things beyond just complexity and scale is also access control. And so when someone logs in and they decide they need to access a VPN, what normally happens is they enter the username and password. Sometimes it's tied with MFA token to gain access. With some of the vendors, they'll do things like device profiling, where we'll profile the device, we'll make sure it's compliant and whatnot. But it really is kind of similar to NAC, right? Network admission control, where we're going to say, are we allowing you to join this network? Because you're really joining the network, especially in a full backhaul case, but even in split tunnel. And the answer is, okay, yeah, you pass these criteria, you get access to the network and whatnot. And if you're doing the Europe or APAC backhaul to New York example, back to the US, obviously that user experience is not going to be that great. But after you get the access, what happens? For one, you get typically widespread access to the network. You might have some firewalling rules that control a little bit of that, but it's usually not very well controlled and policed, which is a problem. For an example of someone like Kevin, who might need access to a marketing slide, but then because he's on VPN, he also has access to the Git server or the repository of information that we're running analytics on and whatnot, because he happens to be on the network, right? So that's a huge problem there. But after that, looking at data movement is typically something that a VPN doesn't do. They're not really looking at the movement of content to and from, doing some sort of inspection and whatnot. That'd be an ancillary, secondary technology that you'd have to put in place to do things like SSL decryption and actually do IPS IDS and things like that. So VPN's kind of like attaching and connecting to the network, and then you're just on it. And it's like you join the device Wi-Fi, and we're approved, and NAC approved it, and you're on the network, right? With ZTNA, it's much more surgical. So you get access to particular applications. It doesn't have to be that you have access just to this Jira server or this repository, the SharePoint on-prem that Kevin needed to access that marketing material. Now all of a sudden, since he's on the network, you can go access different repos, different code, different places like that. With ZTNA, it's really, really specific. It says, no, Kevin can only have access to this particular SharePoint repo on premise. He doesn't get access to GitLab. He doesn't get access to this data lake that we might have, even though he's on the corporate network. And so with ZTNA, you can be much more specific or surgical. One of the other things you can do that is a differentiator and you should look for is applying the same types of controls you would apply with respect to SaaS applications to your internal apps. And it doesn't matter where they are. They can be on the corporate network, they can be in IS infrastructure or whatnot, but you want to be looking at the data movement. You want to be looking at the classification or the taxonomy that we talked about before, and looking for threats too. So if someone happens to upload something and it's an internal application, there may or may not be anti-malware inspection that's going on. So if I were not doing such and not looking, maybe it's an app I deploy in AWS. If you're not looking at the S3 buckets and scanning them for threats, now all of a sudden I have a weaponized piece of malware sitting in a S3 bucket, let's say, and people can have access to that, be it through an application that's written on top of AWS, and we don't even know that there's a threat inside of this Office doc or innocuous PDF, right? So tying, again, the risks of threats with data exfiltration and doing inspection is really important, and is something you should ask about from a ZTNA perspective, because a lot of times what people have done, because of that onslaught, because of that increased requirement for connectivity and whatnot, and controls, is they looked at VPN alternatives, okay? And if you Google that and you find VPN alternatives, you're gonna find all kinds of ads for ZTNA, okay? But a lot of those are just access control. So a lot of those are, okay, I'm gonna replace my VPN, I wanna scale it out, I wanna be more specific, but I'm not actually looking at the data. And the data is really important for the same reason that it's important in SaaS. So think of your apps as your apps, regardless of if it's a license, like you're renting from a subscription perspective from Microsoft or Google or whatever, or something you developed yourself. It's also important there to provide the same types of policies. Cloud-centric deployment is really key too, from a scalability perspective, and obviously something that's fast and easy to use is really important too. So if we look at something like this, ZTNA for any app anywhere, this is really an architecture here where you have basically a private network or a private access provided through a SaaS cloud, okay? So I can have, and this is not to say that you have all these things, but typically people have things like their corporate data center, which has some apps running in it, be it Jira, Confluence, or some devices I may need to RDP or SSH to or whatnot, right? I might also have AWS or GCP or Azure or whatnot, or some other cloud service or some colo that's hosting my my information. And maybe it's not my own corporate data center, but I pay someone to host it. And what you're looking for there is protection from both managed devices and potentially unmanaged devices. And so in an unmanaged device use case, what's kind of interesting is that you may give access to someone who's a contractor. So if I'm working with a partner, for someone that I don't necessarily manage their machine, what can you do? And with VPN, you are going to require them to install a VPN client and turn on a VPN connection and whatnot, install software. That may not be feasible for some of the people you're working with. There are different approaches that also allow you to do things like agentless ZTNA, which is a unique feature actually to the market, and very few vendors actually offer. Not having to install any actual software on the endpoint. But a key thing also to point out there is that when you think about these different things that you're trying to provide to your end users, you don't want to get bloat on the device. You don't want to have to, you remember to use ZTNA agent A for this use case and VPN agent B for this, and then secure web gateway provided through a third, whatever it might be, vendor on the endpoint. So if you're talking about managed devices, what you want to have really is that consistent posture with respect to a unified type agent that can do everything too. But also for the contractor use case, something that is agentless is also desirable. So there's a mix of different things up here that are bought or purchased applications that are deployed like Tableau or Calibra versus something you might have developed in Google App Engine or whatnot. And it can reside in any one of these things, but you want to provide the same type of connectivity across all of them and the same types of security, regardless of where the app is located and regardless of what type of device is accessing that particular application. So from a security posture perspective, we have similar recommendations as we were talking about before, but slightly different. So one is make sure that you're doing this contextual access control and multi-factor authentication. Identifying and determining and really getting that thumbs up that this person is this person they say they are. And that doesn't have to be all the time. It can be triggered off of, I did it once and we know who you are, but then all of a sudden we detect a new device that you're using or a different type of location that you didn't originally originate from. And now we're going to do step up MFA. Or maybe you're trying to download some content and the content is sensitive content and we don't want to give it to you right away. So we're going to require you to do another multi-factor authentication to make sure we know who you are. But the key things that we were talking about before still apply. Blocking the proliferation of threats, thwarting data exfiltration, and again, that can be purposeful or accidental. But DLP plays a big part in that, as well as anti-malware. And so integration-wise, we didn't try to build our own anti-malware. We partner with the top vendors for that. Things like CrowdStrike and Bitdefender and Cylance are all options to do that analysis. One of the key things there, though, is that again, typically when people hear those names, they think, oh, I'm going to have to install something on my endpoint. That's not necessarily true. And so what Bitglass has done, which is different, is deployed the OEM software basically in the cloud. So you don't have to actually install anything on the endpoint. And even in that agentless ZTNA example, where I'm accessing it as a partner and I don't have control over their device, you can still do anti-threat protection, which is quite unique. The key things there, though, is that the protection needs to be provided regardless of the access method, so that if someone were to log in and access it agentlessly, you provide that anti-threat and that DLP and whatnot. But then also on the managed device, they can do various things. And there are two differentiators on what you can do with respect to agentless versus agent-based ZTNA that I'll get into in 1 second. And sometimes there's complexity involved in that for non-corporate devices. The contractor, partner, doctor, BYOD example that we talked through throughout this whole SASEDay. From a perspective of agent versus agent-based, what you have going on here is basically a focus with agent-based ZTNA on kind of all the apps and thick clients versus more HTTP or HTTPS focused web applications. For the agentless focus, what we basically have done, which I'll show you in a second, is rolled out a capability to use the reverse proxy technology, the AJAX VM, if you guys have followed Bitglass or talked to us ever before, but apply it to an internal application. Okay, so we have this ZTNA client connector that you deploy in your IS infrastructure, your data centers. It reaches out to the cloud, so you're not exposing anything externally. I have an architecture diagram in a second. But that connectivity is established. You get these different connection points that are maintained. And then when a user does log in, they can, for example, in the agentless use case, click on a tile and have them taken to the app. So since the app is not exposed to the internet, they can't go directly to the URL. Whereas with agent-based ZTNA, you would be able to do that because I have an agent already and we know, okay, I know this domain is in this particular data center. So I'm going to route the traffic over the ZTNA tunnel, right? With agentless ZTNA, since we don't have that SP-initiated authentication tied into single sign-on that was mentioned a bit ago with Matt and with Ben, there's no redirect back through the IDP and whatnot. So what you do instead is more like similar to kind of that Okta launcher type thing. You land on a page, it shows you this application. I know I want to go to that app, so you click on the app and it takes you there. Okay, and you set up policies in the cloud-based offering and whatnot that connects to users. Identity can be tied into a third-party provider like an Okta or Bitglass can provide it. So in the actual use case of that partner or that contractor type use case, if you didn't want to create them in your directory system, in your backend AD, for example, or Okta or whatnot, you could create them inside of Bitglass as a local user and then manage them that way, which is kind of interesting from a perspective of identity access management. With the agent-based aspect, you also get capabilities to do things more than just HTTP and HTTPS. So I can use a thick client, for example, like an RDP Microsoft Remote Desktop, and connect to a remote device and whatnot, and administer it for whatever I need to do. From a SSH perspective, same kind of thing. I open up the terminal and I SSH to something, or I open up the browser and I go to an actual domain. And because of the routing that occurs by the lookup, we're able to say, oh, this is in data center A that happens to be associated with a VPC in AWS and take me there and whatnot. So I mentioned this verbally a second ago, but the architecture looks kind of like this. We have these connectors. Typically, people are deploying 2 or 3 at minimum in a single location so that you get, for one, multiplexing and path monitoring over multiple connectors, but you also get redundancy so that if one is path monitored and it happens to go down, then we don't route traffic over the dead tunnel. For scalability, you can have more than one as well. But what's going on here is that inside of the customer environment, you have this ZTNA connector. This, if it's VMware or whatnot, it might be an OVA. If it's AWS or Azure, you might deploy a VM or an AMI and basically install the packages and run a client on top of it. It's a container basically that runs inside of a Linux instance, and it reaches out. Okay, so there's configuration for it to reach out to Bitglass. It connects to your tenant in the cloud. There's ZTNA servers there and a router and whatnot that route the traffic over this existing tunnel. So this tunnel stays up, and it's what allows someone to go in, if they're an unmanaged device, see a tile, click on the tile, and have it route the traffic over this tunnel to app.example.com. Okay, and as you'll see in a second, this app-example.com is a similar type of rewriting that occurs with respect to the reverse proxy if you were using that from us as well. So consistent policies are one key thing there. User experience is very similar if you're using the reverse proxy from a URL rewrite perspective. And then on the managed devices, you can just go directly to the URL. There is no rewrite. App.example.com here gets routed through this existing tunnel through the customer firewall. You're not, again, exposing it to the internet because it's an outbound connection, not an inbound one. Over an existing tunnel, and then you get that connectivity. So from a high level perspective, I'll do a really quick demo of this. So in the interest of time, let's jump in here and focus on 2 things. One is the admin portal, and then second is the user experience. So in the admin portal over here, you have basically ZTNA apps. The ZTNA apps are configured much like custom applications. In this particular example, we have Splunk. And so what we've done is we've developed an internal Splunk instance that happens to be hosted in AWS. It's not accessible to the internet. We're going to run it on port 8000 and whatnot. So you configure that application. What you then configure, though, is a policy, too. And so the interesting thing there is, remember, it's not just a connectivity type thing. It's also a data movement and control. So you can use groups to control from your directory store who the users are. You can use a device to identify the device is compliant or not. You can say you can only do this from a particular location. Maybe it's in the US, and if you're outside the US, you don't get access to Splunk. And then data movement. So data movement wise, we're looking at things like in the download direction, applying certain things like, you don't get to download anything. In the upload direction, we're looking for sensitive content with respect to, blocking threats and whatnot, and providing custom notifications for the end user. So when someone goes and they log in, let's say they log in this portal. This is an agentless example. So I have no software installed on this machine to do this. And I enter the password right. Then I get access to a launcher here, basically, and we see that same application. So we got the ZTNA Splunk over here. You see this Splunk instance. It tells you what data center it's located in. We called it ZTNA Acme in that particular example, but you click on the app, and what it's going to do is route you to the Splunk instance. So remember, this is not accessible on the internet, and you get to log in. I don't have this set up for single sign-on right now, which a lot of the internal apps may or may not have. So you might have developed them and whatnot yourself and haven't done that integration quite yet. This, I guess, is a twofold demo here of our Splunk app that you can deploy as well. But now I have access to this Bitglass app inside of Splunk, and I can do my analysis and whatnot. And now, since I'm on agentless ZTNA and we're proxying it through this reverse proxy, you see this URL rewrites here going on to this ZTNA usbitglass.net. And maybe I want to copy this. So I decide to download this, and I say I want to export this as a PDF. But since we don't want that to happen because you're coming from an unmanaged device, and we'll let kind of Splunk generate that PDF on the fly there, we're going to look at the content and we're going to say, hey, this might be sensitive content. What we have here is a report about activities that are matching things like DLP events and various different things that are happening inside of my SIM. So we're going to block it. So we have these custom message capabilities here that you can define that says, this is not an acceptable use of the Splunk instance. You can only look, but don't download. So in the short term, kind of as a high level summary here, what's going on is we're connecting through this application through a tile through, let's say I'm a contractor, maybe I'm an MSSP that's getting access to this to manage the instance, but they can't download local copies of that information. So basically what's going on is that we've combined the capabilities that exist in the cloud, be it things that are specific to zero trust network access with things that are SASE specific, like identity and visibility, or personal device access. In that example was a ZTNA example from a personal device. But if you did have the agent, then you could combine other things like SWIG capabilities to do acceptable use type policies and whatnot. So at a high level, Bitglass is basically this SASE platform focused, but also integrated with the WAN edge stuff, but it focused on this security service edge type capability, which is an aspect of this data protection and security side of the SASE thing that's going to be this new MQ for this year. So I'll stop there and open it up for questions. Let me see what we have. Okay. What types of apps are most commonly protected by ZTNA? I would say that on average, there's probably, 60 to 65% of the apps, maybe a little bit higher, associated with HTTP and HTTPS web apps. That happens quite a bit. Then you get the mix of people that need to do DevSecOps type capabilities. So they're either developers or ops people or security people. And that typically involves things like RDP and SSH, maybe for, 30% or 25% of the rest of that. And then you have this 5 to 10% of other types of protocols. So people might need to do FTP, people might need to do things like CIFS type file shares and stuff like that, and whatnot. So primarily HTTP and HTTPS, then secondarily RDP and SSH, and third kind of other protocols. And the last question we have time for here is, what are the trade-offs between ZTNA implemented as part of a platform or as a standalone implementation? Okay, so from a platform perspective, I think it goes back to what I kind of talked through pretty quickly a second ago. Really, if I'm just doing ZTNA, for one, a lot of times people don't have, vendor competitively, don't have a lot of that data inspection. They don't have a lot of that anti-malware and that DLP and that SSL termination going on at all. Normally it's that NAC type analogy of, you get on, you get access, and that's it, kind of like the VPN, right? Whereas with Bitglass here, you're also being able to inspect content as it moves. But secondarily, it's also tied into the rest of the platform, right? So you get the rest of the UEBA capabilities. If you're using the agent, you get some of the SWIG capabilities too, although there are other agentless options for SWIG too. But in general, you get things like acceptable use policies, blocking of threats and whatnot, and then CASB integrations as well. So if I need to use, the Outlook that client on a managed device and the SharePoint sync client and whatnot in a Microsoft example, then I'm able to do so on the managed device, but maybe we force everything through the web and everything through agentless ZTNA on the unmanaged devices or the partners, right? So I think it's really a platform type thing per se to answer that question, whereas you have a point solution versus one that can protect all three of these things up here: the managed applications, the internal applications, or the web and unmanaged apps altogether. So with that, we'll end the session. But if you do guys have other questions or want to see this in practice, go ahead and reach out.